That's the joke for today. All right. Solving problems involving rates. So we've done this, but now there's a word problem attached to it, right? So convert and extrapolate. By that I mean, right, proportion. You know you're going to have to set up a proportion, which is basically, right, number, and there's going to be a question mark number, something like that. And the key here is you will get some sort of rate, and they'll ask you for, they'll give you one and they'll ask you for the other. Then you know you have to set up a proportion, right? So that's really how this goes, okay? So our car travels at 50 kilometers per hour. How many miles? Okay, it's asking for how many miles can it travel in 7 hours. So before we do anything, we want to convert this to miles per hour. I mean, you can do the conversion after. It doesn't really matter when you do it. Just don't round too soon, okay? That's the only thing here that we're going to emphasize today. Don't round too soon. So I'm going to go 50 kilometers in 1 hour, and I'm going to turn that into miles. Let's do miles. So I'm going to convert. I know that 1 mile has 1 point, and you don't erase if you've done this after, okay? You're going to be okay. So I cancel the kilometers. Perfect. And the hours I want to keep, so I don't need to do anything further with time. Okay, so 50 times 1 is 50, and then 1 times that is just 1.6093. I know some of you are thinking this is weird. Okay, it is weird to do it that way, but you'll know that sometimes this will go on for 3 or 4 different rates. And so I want you to multiply everything across the top and everything across the bottom and then divide afterwards. Otherwise you might make a mistake. So when you divide that, I need to use my calculator on this one because I did it slightly differently on my key. You get 31.0694 and something miles. So miles per hour is technically the unit we have here. Okay. So if I know that I can travel 31.0694 miles in 1 hour, now I am shifting over to this. Okay. It's asking how many miles can you travel in 7 hours. So when you're given one of the units, right, and you want to know what the other one will be accordingly, then you set up a proportion. That's what I would suggest. So you go to the side of the variable. For us, most of the time it's going to be on the right side, okay? But you cross multiply and then you divide. So you go 7. You don't need to do the units here. I'm just showing you how that works. This is miles, okay, like that, and then you divide by 1 hour, which is irrelevant, I know, but it's part of showing your work, right? So the hours will go, and all you're left with is miles, which is what we expected, okay? So when you multiply 7, so I like, especially with those other calculators, you'll be able to use all decimals. You can actually go up with an arrow, copy, paste what you did before, and continue working with it. So you have no excuses there, right? So it's 217 point rounding now. So the final answer, you do round to 2 decimals. That's the standard for grade 12 applied. And so I'm getting you ready for that. So angles, you name it, 2 decimals. I know you're not used to that. It's going to be weird because you were always used to rounding angles to a whole number. We round everything to 2. Okay, so 49, and in this case it's just miles, right? So that's how many miles you're expected to travel in 7 hours. Okay, so there we go. Some converting, some extrapolating. Extrapolating, you're going extra, right? You're going outside the smaller sample. Okay, so a small boat uses 2.4 liters for every 3 hours. It's kind of weird, right? How many gallons will be required to run the motor for 12 hours? There's that gallons, right? So you need to somehow get your liters to gallons. So I will do that. So 2.4 liters in 3 hours. And I know that 1 gallon has 3.79 liters. That will allow me to cancel out the liters here. And the hours are okay. I don't need to change that. You may have to, right? Read carefully. You may have to change that to minutes, seconds, what have you. You're okay in this instance. So 2.4 times 1 is just 2.4, and you're in gallons. And then 3 times 3.79, that's 11.37, right? Just checking. Yeah. 11.37 hours. So you're basically saying it's this many gallons in 11.37 hours. They're equivalent, right? You just state it in a different unit. Now, I want to show you something else. Yes, you can divide and then get your answer there, but you can also use it as is right now. Okay? I will show you both. So this, if you go 2.4 divided by 11.37, that is this, 0.21108 and something, and that would be, you're left with gallons, right, per hour, for 1 hour. This is what we call a unit rate. Every time you divide, this is a unit rate. This is just a regular rate where you have numbers other than 1, okay? You can use this or this. It's up to you. I'm going to use this because this one is too ugly here. So I'm just going to say 2.4 gallons in 11.37 hours. And the question is, in 12 hours, how many gallons will you use, right? That's the question. So to find x, you cross multiply and divide again. So it'd be 12 times 2.4 divided by 11.37. Right? And that's 2.53, right? 53 gallons. Good. And if you're still, you know, if it's sometimes it's not working out for you, just keep trying, right? Just keep working at it. You will succeed. Okay. So again, I'm going to repeat this. If you had used 0.21108 all decimals over 1 hour, right? If that's would have been your setup, you would have arrived to the same conclusion. Okay. So you can use this one or this one. Both of them are gallons, hours, right? Both of them. Okay. And now I kind of alluded to it. Now I'm going to make sure you understand what the difference is between a rate and a unit rate. Okay. So here we go. I'm going to have to write down a few things. I'm going to give you a formula as well. Determine the better rate. Okay. So if you're ever asked, like, which one is the better buy, which one's the better purchase, in two stores, you're buying different items, you want to get your unit rates. Okay? Units need to be the same. Convert as needed, so that's important here. I'm going to use a different color to make that stand out. Okay? Units need to be the same, and then determine the unit rate. You basically go numerator divided by denominator. State the better rate and by how much. That's also important. State the better rate and by how much. Make sure you keep these booklets right till the end, okay? So I'm going to give you an example. You go to the store and you see a pack of produce, let's say potatoes. Hey, a bag of 3 pounds is $2.99. That would be a rate. How do we know it's a rate? Different units, right? The unit rate is when you divide. You go $2.99 divided by 3. So you basically go $2.99 divided by 3. And that would actually be $1 per pound. If you rounded that correctly, you get $1 per pound. So a unit rate, what should I say here? I'm just going to make sure you understand that. For the most part, it's going to be $1 for 1 unit. Okay, that's basically for the most part what you're figuring out, right? How much money is it for 1 pound? How much money for 1 kilogram? How much money for 1 liter? And so forth. Okay, that's what unit rate is. I want to remind you, because some students flip this. They put the money at the bottom and the quantity on top. When it comes to money, when money is involved, always go cost divided by quantity. So I kind of tell my students, right, always go money on top and the quantity at the bottom. Like somewhere next to unit rates, maybe just have that to help you. Don't flip them, okay? So I'm going to circle that. Another thing too, every once in a while it creeps up, it's fuel economy, the amount of fuel used per distance traveled. And it is usually stated, so I'm going to highlight that part, fuel economy is usually stated as liters per 100 kilometers. So I'm going to give you a formula for this one. Okay? Fuel economy, all you need to do, if I ever ask you to calculate the fuel economy, you go liters consumed divided by the distance that you traveled, and you multiply that by 100. Can you see that? Hold on. I'm just going to bring this up a bit for some of you back in the back rows there. And when you get an answer, your answer will always be stated in liters per 100 kilometers. Yikes. That's messy. Let me try that again. Liters per 100 kilometers. Okay, so that's if you want to add that to your study sheet, I would strongly recommend that because you're probably going to forget. Okay. So this is kind of what everything hovers around, converting and extrapolating, and then every once in a while a fuel economy question. You got to know what a unit rate is. Basically, if you have a rate, just divide it, and then you were doing that actually while you were doing the homework, you were taking your rates and converting it to unit rates every time. Okay, so we're going to use this to answer the following. Okay, so I'm going to do one, and I'm going to give you a little bit of class time to try some on your own. So here we go, page 6. So which is the best buy and by how much? So you've got a 12.88 kilogram turkey at Safeway, okay, for $42.89. And you've got a turkey at Superstore. The turkey at Superstore at $149 a pound. This is already a unit rate. Okay, Superstore was kind enough to do the work for us, so we know what it is per pound. But we still need to have a little bit of work to do with Safeway. So we're going to go Safeway. And remember, dollars on top. So Safeway is basically just giving us the package deal. This much money for a 12.8 kilogram turkey. So what's the problem here? The problem is that Superstore has their price per pound. We still have kilograms conversion, right? So we're just going to do a little bit of converting before we turn this into a unit rate. You're with me, right? Okay. All right, so this kilogram, I want to cancel out. So I'm going to go 1 kgs here, and I know that that is 2.2 pounds. I hope you remember that. Okay, so you can cancel these out. And you end up with, you just go, this times 1 is 42.89 over 12.8 times 2.2. 28.16. And the units that remain in the denominator are pounds. So perfect. Now you're closer. But this is just a rate. Okay. This is a rate right here. We're going to turn this into a unit rate. So we're going to divide this as is. Okay. So 42.89 divided by 28.16. Here you go. That ends up being $1.52 per pound. Okay. So if you want to make a little note here, we are doing some conversions. Then we get a new rate where there's pound now, and then we get to this point, which is a unit rate. Okay, so we did converting, and then we figured out a unit rate, which is what you did during your homework the whole time. You were doing that the whole time. So don't think this is new. Okay? I just need to make sure you get this part. So which one is better? Superstore, right? It's cheaper per pound, right? So you have to state that. Superstore is the best buy. You save. You can do this on the side here. You save 3 cents per pound, not just 3 cents, but you save 3 cents for every pound. Is that worth it going to another store? That's up to you. But if it's purely money, you would say Superstore is your best buy. Okay. So which one is the better one, and by how much, right? So that's what we're doing here. Okay, same reasoning. Okay, same reasoning. I'm going to ask you to try B here real quick. Okay, so you have a car that's traveling at 14.2 meters per second. Okay, understand that that's meters per second. And you have a car going 50 kilometers per hour. Let me see here. I'm going to say just so we're kind of all going the same path. Answer in kilometers per hour. Okay, so that means that you're going to have to convert that meters per second to kilometers per hour before you say which one is faster and by how much. Okay, if you did it the other way, that's fine. If you already did this and you went meters per second, that's fine. I'll give you the answers for both. But just give this a try, and if you're done that, you can try the second question as well. Okay? Pause here. Study sheet. But 1 hour has 3,600 seconds. Maybe some of you need to have that handy, especially to tackle one like this. Okay? So keep going for a bit longer. I know a lot of you, I looked at your answers, they look good, so I'm just going to make sure everybody's on the same page, okay? So that's what I always need to make sure as a teacher, that everybody's on the same page. And if you like the 100%, you got to watch out for the little things, right? If that's who you are, you want to strive for that, watch out for the little things. So here we go. This one right here, which one is faster? So we got to convert, right? So you got to bear with me because I have my answer in meters per second. So just follow my lead here. So 1 kilometer has 1,000 meters. A lot of you would have benefited from this one, but that's okay. If you did it a different way, that happens. 1 hour has 3,600 seconds. Okay. So if you do the top, you get 51,120. I have a feeling that your answers might be slightly different than mine, and that's okay. That happens because those conversion rates are sometimes slightly rounded, right? They're off by a little bit. So I'm just going to divide that by 1,000, and you get 51. Please remember your units. So that's 51 kilometers per hour. So this is your rate. You could use this already if you needed to calculate, but this is the unit rate right there. So you usually get a mark for that. And then now that they're both in the same unit, you can say that 14.2 meters per second is faster by, and then this is mental math, right? 1.12 kilometers per hour. I know it's weird to have 2 decimals there, but that's just how we roll, okay? Miles per hour and meters per second. I will tell you this. If you convert the meters per second, you get 44.74 miles per hour. Okay? And then obviously you say that 20 meters per second is faster by, and this one is also a good mental math, 14.74 miles per hour. Okay, so I'm not going to go over that one. The key will show that, so if you want to look at the key, it's actually posted already. Yesterday I posted it, so you can just check it out if you're stuck on that one. I want to do fuel economy here, and I might have to leave Reynolds for tomorrow. Yeah, I will leave Reynolds for tomorrow. I'll just let you work a bit more on this kind of stuff, all right? Appreciate it when I slow down. Take advantage of it, all right? So which car has a better fuel economy? Immediately, you should think of the formula, right? And it's basically liters divided by kilometers times 100, okay? Oops, you can't see that. There we go. You should be thinking, oh, okay, we're in fuel economy territory. I can't just do what I did before because it's got to be stated a certain way, okay? So for car A, it's already perfect. It's liters. So the fuel economy there is 32 liters over 500 kilometers. I multiply that by 100, okay? Let me just get my key here. It's 6.4 liters, right? 6.4 liters per 100 kilometers. You state it like this, okay? And for car B, I needed to do some converting. So to be honest, it's up to you. You want to just tackle gallon, turn that to liters. You want to turn the miles into kilometers separately, that's fine. You could do this if you want it. A lot of you I saw, because you're used to it, right? That is a rate, okay? So I'm going to go tackle gallons first. 1 gallon has 3.79 liters. Cancel the gallons, perfect. Tackle the miles. 1 mile has 1.6093 kilometers, right? You get that. You get at the top here, you get 40, sorry, let's cancel the miles first. You get 43.585 liters, okay? And at the bottom, if you multiply this out, you get 482.79 kilometers. Is that all right? And now I'm going to use my fuel economy formula. The liters, do not round just yet, divided by the distance traveled, which is this many kilometers, and you multiply that by 100. When you do that, you get 9.03 liters per 100 kilometers. Okay. If you get a really, really big number or a really, really small number, maybe just check. Maybe something went wrong when you plugged it in. Okay. So which one is better? Is more better? Is less better? When it comes to fuel economy, less is better. Okay. I hope you understand that, right? Because you use less fuel for distance travel. So car A has the better fuel economy. So you don't want to lose marks. You might think, dropping the mic, I'm done, right? But no, you want to make sure you answer the question. Car A is a better fuel economy by 2.63 what? Liters per 100 kilometers. Like if you subtract their fuel economies, you got to stick with the units that you've used to figure out which one is better. Okay, so this is right here, your final answer. If you want to know the breakdown, it could be a little different, but I would usually give you probably half a mark for doing this part because there's no conversion. I'd probably give you a mark here, and I'll probably give you a mark here as well for saying which one and by how much, right? So 2.5 marks more or less in this question, so keep that in mind. I will say the rest of this page, I will say homework. So I'm just going to make an arrow going down for you to try. And you stop at Reynolds, okay? So if you go to page 8, there's Reynolds. I want you to stop there. We're going to tackle that one tomorrow. But this isn't, honestly, this to me is just basic. So I will add a bit more, okay? And you decide how well you're doing at this point. So hold on, I'm going to skip a few pages because I have a worksheet that I've inserted. So this will be page 13. because I can also tell that some of you already finished this page. Good, that's awesome. If you're done this page, you go to page 13 and just work through that worksheet, which has various conversions so you don't forget. I think 13 kind of bleeds into 14 a little bit. Stop giving us more. I know. So I will just say page 13, 1 to 3, okay? Because the third question bleeds into page 14. So you can do that right now. I'm getting a sense that, you know, you're working, you're doing what you're supposed to do. That's what I like to see. And oftentimes I let you work because I want to see what you're thinking, what your questions are, and I can clarify it that way. I will post a bunch of pages, so you just go find the question you're stuck on. You can do that, right? 10 minutes left, so if you want to listen to music quietly, that's fine. If you need that. If you don't need it, even better, okay? That's it for today, guys. Thank you.